Okay, this is section 13.6 in our textbook. It's our inverses of trigonometric functions. In this section, our objectives include evaluating inverse trigonometric functions. So basically, we're going to look at inverses. These are our vocabulary words for this section. The inverse of each of the different functions that we've talked about since this first section. When we evaluate a trigonometric function for a given angle, we can find, in addition to the trigonometric function itself, we can also find the measure of the angle given that we have the trigonometric function. We do that by using the inverse trigonometric relation. So let's first look at our function. We've got sine of theta equaling a. In order to do the inverse of that, we take the inverse of sine of a, and that would equal theta. So it's very similar to what we've done all along in algebra related to doing the opposite or inverse step. If we're looking at cosine theta equaling a and we've been given a, we would take the inverse cosine of a to find theta. And lastly, when we have our tangent and its inverse, we would have the tangent of theta equaling a, and we'd find theta by taking the inverse tangent of a. When we read this, it's read as the inverse of sine, or the inverse sine. Does not mean that we are talking about the reciprocal of the sine function. If you remember, the reciprocal of the sine function is cosecant. The inverses of the trigonometric functions are not functions on their own because there are so many different values of theta for a particular value of a. Let's look, for example, at the inverse cosine of 1/2. And if we take a picture, we can see from our unit circle here that we've got two locations that give us the cosine of that angle being equal to 1/2. So cosine pi over 3 equals 1/2, and cosine 5 pi over 3 equals 1/2. Here in our first quadrant and our fourth quadrant. And then if we were to continue rotating around and around and around, every time that our terminal side fell on either one of these rays, we would have another cosine of that particular angle equaling 1/2. So based on that, we do have multiple locations where the cosine of an angle is equal to 1/2, and so we don't have a function when we're looking at it in this point of view. We're going to find all possible values of, in this case, inverse cosine of root 3 over 2. Our first step is to find the values between 0 and 2 pi radians for which this cosine of theta is equal to root 3 over 2. Now we've started to memorize this, so I really hope that you're going to take the opportunity to do this from memory. So draw your unit circle and figure out, when we're looking at it, we've got two locations where the cosine of an angle is equal to root 3 over 2. Again, both angles are on the right-hand side of the y-axis, one being in quadrant 1, one being in quadrant 4. Next, what we're going to do then is set it up this way. We've got cosine of pi over 6, cosine of 11 over 6, 11 pi over 6. These are the coordinates, or the x-coordinates of the points that are on the unit circle. Our next step is to follow through on this so that we can identify in general all the possible values of inverse cosine of root 3 over 2. So basically every single time a coterminal angle has that terminal side in the same spot where pi over 6 does and 11 pi over 6, then we have a scenario where the inverse cosine would be equal to root 3 over 2. And when we think about rotations, we think about 2 pi being a full rotation. And every multiple of 2 pi will make that continue in the same pattern. So this is how we look at putting that together. And we can see from this scenario that n here is our multiple of the full rotation. This is 2 pi is our rotation. And so we have 2 pi as our rotation, and n indicates how many multiples or how many times we're going to make that full rotation. I'm going to give you an opportunity to work this out yourself. I would like you to find the inverse tangent of 1, pause the video, return when you're ready to check your work. Okay, just like the last time, the first step is to find the values between 0 and 2 pi radians where the tangent of theta is equal to 1. So here's our picture. We can see that it's across from each other. The first one happening at pi over 4 and the next one at 5 pi over 4. Our positive values, root 2 over 2 over root 2 over 2 in its ratio will give us the value of 1. The two negative values here, negative root 2 over 2, negative root 2 over 2, in a ratio of y to x will give us a value of 1 as well. So these are our two locations, and we would take the points, the x and y coordinates, in order to figure this out. Next, what we're going to do is adjust this so that we are looking at all possible values of the inverse tan of 1. So we want to find the coterminal angles, measuring pi over 4 and 5 pi over 4 radians, and all of their coterminal angles to that. Taking into consideration 2 pi as our full rotation and n being a multiple of that. We're missing an n here, so there should be an n right next to this. This 2 pi should have an n next to it as well. Okay, and that's how we determine all possible values of inverse tan of 1. Because we do have more than one value, or more than one theta that produces the same output value, we often find ourselves in a scenario where we may want to restrict it so that we only get one answer, and then we actually do have a function. We'll see later on as we work through our Algebra 2 that we're going to do this as well with our square root function. And so we're going to restrict our domain here so that we only have a single result that comes out. Our trigonometric functions with the restricted domains are separated out from the ones we just talked about, and we indicate the restricted domains when we use capital letters to identify these functions. So you can see sine, cosine, and tangent all have capital letters here, and that means that their domain is restricted and they are a function. So let's look at what they look like. So when we're talking about sine theta, we're looking for sine theta between negative pi over 2 and pi over 2. So on the right-hand side of the y-axis. So we have both a positive and negative scenario here. When we're going to cosine, it's across the top, quadrants 1 and 2. And our restricted domain when we're talking about tangent is the same as when we're talking about the sine. So you can see some of the details here. Each of these are capitalized, indicating we're talking about a restricted domain. And because of that restricted domain, we now have functions. These functions can be used to identify the inverse trigonometric functions. Each value of a in this domain has only one value of theta. Therefore, even though inverse tan has many values, capital inverse tan of 1 has only one value. Looks like we're missing a 1 here. So let's go ahead and add that in. That should have, therefore, even though inverse tangent 1 has many values, if we capitalize it like we did here, we have only one resulting value. And that value is where theta is equal to pi over 4. This is a synopsis of what we just talked about. You may want to take a picture or pause and copy this down into your notes if you don't already have it in the study guide. We have another way of identifying these particular inverse trigonometric functions. We use the words arc sine, arc cosine, and arc tangent when we're talking about the specific functions where we've previously identified they have capital letters. So now we're going to look at evaluating a inverse trigonometric function. We're going to give our answers in both radians and degrees. So we have here inverse cosine of negative root 3 over 2. We notice that the c is capitalized, so we're looking at restricted domain. When we consider our restricted domain for cosine, it's just the top part of our unit circle, so from 0 to 180 degrees here. And we know that cosine is negative in the second quadrant, so that gives us this particular angle from 0 around to this side where our cosine is negative root 3 over 2. That particular angle is 5 pi over 6, or 150 degrees. We set it up algebraically to find where cosine theta is equal to negative root 3 over 2. And we find that happens at 5 pi over 6 algebraically. We look at our values in the restricted domain and the x-coordinate, the points of the unit circle. So we've kind of looked at this specifically on the unit circle. Now in numerical sense, this is what it looks like. Looking at for the second example, in evaluating the inverse trigonometric function, inverse sine of 3/2. We're considering this to be a function because we have a capital letter S in front of the word sine. We do have to realize that the domain of the inverse sine function is found between negative pi over 2 and pi over 2, and those values of a would be between negative 1 and 1 if you consider the unit circle, and that caps out at negative 1 and positive 1. So when we consider 3/2, we determine that 3/2 is outside of that particular domain, and that means that the inverse sine of 3/2 is undefined. We'll look at that in a little more detail, and you can ask questions on that when you come into class. I'm going to give you an opportunity to work a couple out yourselves. Pause the video, find the inverse sine of negative root 2 over 2. You have a unit circle drawn on the side to help you out. Resume the video when you're ready to check your work. Okay, looking at our unit circle here and figuring out some details, we know that the inverse sine of theta as a function has a restricted domain, and we're looking for this domain between negative pi over 2 and positive pi over 2. So on the right hand side of the y-axis, we know that sine is negative in the fourth quadrant, so our angle is going to be on the bottom side here, and that angle can be done as a negative angle or as a full rotation, but we're mostly looking at that negative angle here where it's negative pi over 4. So because we want this between negative pi over 2 and pi over 2, we're going to use our negative pi over 4 angle for this inverse sine of negative root 2 over 2. We can calculate that both in degrees and radians. And that degree measure is negative 45 degrees. On the next one, we're now looking at the inverse cosine of 0. Pause the video, resume when you're ready to check your work. Our cosine function, the inverse cosine function, has a restricted domain to the first and second quadrant. So determining where cosine theta is equal to 0 is only going to occur at the top where cosine, where the theta is pi over 2. Using our x-coordinates here, that makes that equal to 0. The angle measure in radians is pi over 2. In degrees is 90 degrees. That completes section 13.6. Go ahead and stop the video and work on your study guide. Bring any questions into class, and we'll see you next class.